In this video, we're going to talk about intervals on which a function is increasing, decreasing, and constant. So we should all know what it means to increase. It means it gets bigger, right? In our context on a graph, it means it's going to go up. Something decreases means it gets smaller or it goes down. And if something is constant, it means it's not changing, right? It's not going up and it's not going down. It's just flat, right? So when we do these, we're going to write these all in interval notation. And the most important thing that we need to remember for every single one of these is to always look from left to right, right? We're not going to say, oh, as I go from right to left, this is going down. No, we will never do that. As it goes from left to right, this thing is going up. That's what we care about. How does this graph behave as it goes from left to right? And we will always, for these, always use x values when we write out our intervals. Our intervals will always be with x values, just like when we do domain. So for this one, we think about when is this increasing as we look from left to right. Well, there's an arrow down here pointing that it's going down and to the left. But if we think about coming from as far to the left as we could go, then really what's happening is this thing is going up from as far left as we could possibly go. Well, as far left as we could possibly go would be negative infinity. And again, any infinity will always have a parenthesis on it for interval notation. As it goes to the right, it's always increasing. There are never any places in here where it stops increasing and starts going down, or where it flattens out. It's always increasing. So this will continue to increase for all of the x values because of this arrow that points to the right and up. So this is going to increase from negative infinity to infinity. If it's increasing for all of the real numbers from negative infinity to infinity, it can never be decreasing, and it can never be constant. And we can see that. There's no places where this graph goes down as you look from left to right, or where it's flat. So this one only has an increasing interval. In this second one, I think we should be able to see right off the bat that, again, it is only ever increasing. It starts over here at -6. That's where it begins to increase, where the graph begins, with a bracket, because it's a closed endpoint. And even though at that specific point we're not actually increasing, you'll find that on a lot of the standardized tests as you get to higher classes and on the SAT and like AP calculus tests, they'll always indicate increasing and decreasing intervals with closed brackets, even at endpoints. As long as the endpoint is actually a closed endpoint, right, not an open circle at the endpoint. So we'll be increasing from -6, and then it continues to increase as the x values get larger forever. It goes up forever. So we'll increase from -6 to infinity. Again, it's never decreasing, it's never going down, and it's never constant. It's never flat. On this one, a lot of students get tempted to say that this graph is increasing because they see an arrow pointing up. But we have to remember that we have to look from left to right. As I look from left to right, this thing is actually going down. It's decreasing. And it's decreasing from an x value over here of, well, as large as these x values get in the negative direction, right? Negative infinity. So this is decreasing from negative infinity until I hit this endpoint over here, which is at x equals 5. Right there at that endpoint, we stop decreasing. So we'll say it's decreasing from negative infinity to an x value of 5 with a bracket. Be careful not to put the y value of -4. Right? Just because we're decreasing doesn't mean we use a y value. We still use the x value. Because this graph is never going up and never flat, we'll say it's never increasing and it's never constant. This one has endpoints on both ends, one of them being a closed endpoint and one of them being an open endpoint. So we should see that there's no infinities on here, and we can just, by visually inspecting the graph, see that it's never going down and it's never flat. So we'll say it's never decreasing and it's never constant. It is increasing from an x value of -3 with a closed endpoint to an x value of +6 with an open endpoint. This time we put the parenthesis at the endpoint because it's actually an open endpoint. That point isn't included in the domain of this graph, so it can't be increasing at somewhere where it doesn't exist. This one gets a little bit more complicated, as the rest of them will. We're going to see that they're not just going to always be increasing or decreasing all the time. This one has a section where it is completely flat right at the beginning, right? It's just completely flat at the beginning from -6, from an x value of -6 to an x value of -2 with a bracket there. And then after that, we can see that it's no longer constant. It starts decreasing, right? So we'll say that it's decreasing from an x value of -2 to an x value right here of 1. After that, it starts to increase. Okay? Now it's going up. Okay? So it's increasing from an x value of 1 to where it stops increasing right here at an x value of 3. But then it picks back up again at 3 and is constant. It's just flat there. So on the constant interval, we'll have to put a u for union and say that it's also constant from 3 until it stops. Well, since it's got this arrow going straight horizontally, it never stops being constant. It'll be constant from 3 to infinity. We'll kind of follow a similar process for this one as we go through and just kind of do each chunk as we go from left to right separately. But the first thing I'm going to do is I'm going to look at it and say, well, there are no places where this graph is horizontal, where it's flat. So I'm going to say it's constant, never. But then, as we look at the increasing and decreasing intervals, the first place that our graph even exists here is at -7 with a parenthesis at -7 because it's actually an opened endpoint there. And then we decrease until we get to x equals -4. Because it's not an open circle, we'll put a bracket there. But then our graph begins to increase. Our graph is increasing from that x value of -4 until we get to an x value of 0. And ones where it's 0 are the ones where it's really common for people to accidentally put the y value. Don't accidentally put the y value there. These will always be x values. So we are increasing from -4 to 0. After that, our graph decreases again. So we'll put a u for the decreasing interval for a union, and then it decreases from 0 to 3. And after that, it begins to increase again at that x value of 3. So we'll put a u for the increasing interval, and it will increase from 3 to, well, that arrow indicates that it's increasing forever. So from 3 to positive infinity with a parenthesis. We'll follow a similar process here. There are no places where this is just flat. So again, we'll say that it's never constant. And then we'll look at the beginning at -6. We should have a closed endpoint, and it should be going down, so it should be decreasing. So we'll decrease from -6 until we get to this x value of -4. Then it starts to increase. Now this increasing interval is a little bit tricky. It starts increasing at -4, But as we go through here, we have this place at -2 where there's an open circle. So we have to actually break it up at -2 with a parenthesis, and then say it's still increasing after that from -2 until we get to x equals 0. So -2 to 0. And the 0 can have a bracket because we have a closed point there. Then we begin to decrease again, so we'll put a u. And then we're decreasing all the way down here until we get to x equals 4. So we'll decrease from 0 to 4. Then we begin to increase again. So we're increasing from 4 to 6. So we'll put another union, 4 to 6. And because it's not a closed endpoint, it's an open endpoint there, we'll put a parenthesis on the 6 and not a bracket. For this one, we'll check as far left as it goes, and this time it has an arrow pointing to the left, which indicates that we need to start one of these intervals with a negative infinity. Right? And so even though the arrow is pointing up, what's actually happening as we look from left to right is the function is going down. Right? So it's going down or decreasing from negative infinity until I get to -4. So we'll say we're decreasing from negative infinity to -4 with a bracket. Then we're increasing for just a little bit from -4 until we get to -3. So we'll put a -4 to -3 on our increasing interval. After that, our graph switches and it is completely flat. It's constant. So we'll say we're constant from -3 until we get to -1. After that, we have a big gap here, so we're not going to have anything between -1 and 0. But at x equals 0, it's now increasing again. So on our increasing interval, we'll put a u for union. We'll put our 0, and this time it's going to have a parenthesis because that's an open circle there. And we're increasing until we get to this x value here of 3 with a bracket. And then we're decreasing from 3 until we get to 5. So we'll put a union, an x value of 3. And because it's an open circle at the end, our 5 will have a parenthesis. All right, this is the last one that we're going to do here. So if we look to the left, there's no arrow pointing to the left, so we'll just start at -6. And from -6 until we get to this jump here at -4, we are increasing. And both sides are open endpoints, so we'll say it's increasing from -6 to -4 with parentheses on both. After that, it's constant starting at -4 until we get to right here at -1. So we'll say we're constant from -4 to -1. Then it begins to increase again from x equals -1 to x equals 2. So we'll put a u, and this time it's a actual point here, not an open circle, so we'll use the bracket. And at 2, it's an open circle, so we'll use a parenthesis. Then we have a jump in the x values. There's no x values between 2 and 3, so we can't be increasing, decreasing, or constant there. But then at 3, right here at 3, we pick back up and we are getting larger. We're increasing as our x values go all the way to the right with this arrow to infinity. So we will be increasing once more from 3 to infinity. And we can see that nowhere along here was our graph decreasing, so we'll just say that our graph is decreasing never. And that's the basic idea of determining when a graph is increasing or decreasing or constant. So remember to always look from left to right, from the smallest x values to the largest x values, and always use the x values, never use the y values.